So in this video, we're going to write some equations for the reactions of the solid halide salts reacting with sulfuric acid, and we're going to think more about whether or not they're redox reactions or not. So this first example that we've got here, we've got solid sodium chloride reacting with concentrated sulfuric acid. And if we just write in the oxidation states of the halide, so chloride is -1 there, and it's -1 there. So the chloride hasn't changed oxidation state, and the sulfur +6 in the sulfuric acid, still +6 in the sodium hydrogen sulfate. So this is not a redox reaction because there is not any change in oxidation state for any element. And in this reaction, the role of the sulfuric acid, or the sulfuric acid, is acting as an acid, and an acid is a proton donor. So we can think of the sulfuric acid as donating a proton, and the sodium chloride, or the chloride, as a proton acceptor in this reaction. So there is no redox reaction between hydrogen chloride produced and the sulfuric acid. The chloride ion cannot reduce the sulfuric acid. Chloride ions are weak reducing agents, and a reducing agent is an electron donor. So we've got a question here that says, predict what would you observe when solid potassium fluoride reacts with concentrated sulfuric acid. Explain your answer. What is the role of the sulfuric acid in this reaction? So just think about what we've just done with the chloride. Think about the trend that we saw from the previous video in terms of the strength of the halide ions as reducing agents, and see if you can predict what you think might happen with the fluoride. So good, even though we don't need to give an equation, a similar acid-base reaction would happen. So we would get steamy white fumes of hydrogen fluoride. The sulfuric acid would be acting as an acid, a proton donor, and an explanation for this is that the fluoride ions are weak, or we could say weaker than the chloride, weaker reducing agents, so cannot reduce the sulfuric acid.